This is what Darwinian explanations totally miss. It's one thing to explain how it looks. It's another thing for it to actually work. All right, and that's what we'll get into. But that's what our book talks about. We're explaining how it falls apart and what it needs to stay alive and continue.
ID the Future, a podcast about evolution and intelligent design.
Is the human body a cosmic accident, or is it the handiwork of a master engineer? Can purely material causes, like natural selection acting on random mutations, account for the coherent, interdependent, tightly coordinated, and precision-tuned systems that life requires? Welcome to ID the Future. I'm your host, Andrew McDermott. Joining me today to help me answer these questions and more is Dr. Howard Glicksman, co-author with Steve Lothman of the new book, Your Amazing Body, a fresh, abridged version of their previous book, Your Design Body. Dr. Glicksman has been a general practitioner and hospice physician for many years. He is now a consultant who mentors hospice physicians in the management of fluid overload, especially due to heart failure. He received his MD from the University of Toronto. Welcome to the podcast, Howard.
Thanks, Andrew. It's great to be here.
So you have over 4 decades of experience in medicine, which gives you a wealth of first-hand observations of the human body's daily operations. You've seen it at work, solving hundreds of hard engineering problems. Now, when did you first begin to realize that what you were witnessing was beyond the abilities of an unguided process like Darwinian evolution?
Well, Andrew, I grew up in a secular Jewish home where God was never mentioned. So, growing up as a teenager, I really had no idea of a creator or creation at all. And I remember being a freshman in high school, my science class, being told about Darwin and chemical evolution. And I remember thinking to myself, well, I guess there's no God, But a few years later, when I was in my senior biology class, I was, reading the textbook, and I read the chapter on the eye and looked at all the different parts, and the chapter on the ear and all its different parts, and how we could see and hear. And I remember thinking immediately to myself, I said, "There's just no way this came for nothing." The Darwinists are over extrapolating and oversimplifying things, and at that moment, I realized that there was a creator. I agreed with intelligent design. So, a few years later, I went to med school, and that I learned how the body works and how it can easily die, and that basically just confirmed in my mind the truth of intelligent design.
Okay. So in your earlier years, you took their word for it, the materialist view, but then upon closer inspection, you're like, wait a minute, which I think is a common, that's a common, refrain for people is to say, oh, okay, well, I guess it must be, I guess it did come about randomly, over time, but then they're faced with some of the evidence and they have their doubts.
Right.
Yeah.
I've heard many stories of people who lose their faith as a teenager, and that's exactly when it happens. They're usually
Yeah.
a teenager in science class. They learn about Darwin, and they lose their faith because they trust what their teachers are telling them, which is the same as me. What do I know?
Yeah. Well, content like this, or conversations like this that we're having are a way of helping people, really ask those questions and come back to the complexity and the design that they see, but seems to be getting explained away by a Darwinian view. It's worth
Exactly.
closer inspection, definitely. Well, I like the way that you and your co-author Steve started the book with some discussion of the 2 main types of causes: material and intelligent causes, and the characteristics of each. Can you break down the distinction briefly of material and intelligent causes for us?
Yeah, this is so important, for your audience. I'd really like to. I've got it written down here, I took a lot of it from the book. Material causes are dependent on the forces of nature and the laws that govern them. So basically, physics and chemistry alone. They are unguided in that they lack desire, intent, foresight, or planning. They therefore must rely only on blind trial and error with lots and lots of luck. Above and beyond the origin of life, with theories from random chemical evolution, the theory of Darwinian evolution holds that the unguided and blind processes of natural selection acting on random variation, or what we call genetic mutation, solely explains the diversity of life. In contrast, intelligent design or its causes act with intention. They build things to achieve intended goals and purposes. Intelligent agents visualize an outcome, plan how to achieve it, and execute the plan. They make specific choices, guide construction, assembly, and activation of the end product. Intelligent agents generate information and give it meaning, purpose, and functional capacity. They design systems that harness the laws of nature to perform tasks that nature can't do on its own. So the intelligent design theory holds that certain features of the universe and of living things are best explained by an intelligent cause, not an unguided material process like Darwinian evolution.
Yeah, and that's a great way to start, I think. Even before you start jumping into how amazing our body actually is, you're laying it out. Here are the two types of causes that, things are coming from in life and the universe. You have material causes, you have intelligent causes, and they're very different. One has foresight, one has the ability to plan and execute. The other is just moving blindly, not to say that it doesn't exist in some limited form, but is it capable of what we're about to talk about? Anyway, I thought that was a great way to open up this new abridged version of your work with Steve. Now, one of the problems you have with Darwinism is that you say it only talks about how life looks and not how it actually works within the laws of nature to survive. Now, what do you mean by this, and how does it relate to why you started writing about intelligent design over 20 years ago?
Yeah, from my experience, Andrew, Darwinism is mostly, as I described, descriptive. It talks about how life looks, and but to survive within nature, the body has to have functional capacity and control, right? So I'm going to give you a couple of examples. This first one is really what got me started writing. I became aware of intelligent design about 25 years ago. A friend of mine, actually a medical colleague, invited me to a talk by Charles Thaxton at the C.S. Lewis Society in Clearwater. And I was amazed that people, that scientists were writing about this and working on that. And I bought his book, and I bought Darwin's Black Box by Michael Behe. And a couple of years after that, a couple of years after that, my son had just gotten married, and he was in Kansas, and I was talking to his new brother-in-law, and there had been a controversy about the teaching of Darwin in science in Kansas at that time. And we got talking about that, and also talking about the fact that he had a couple of relatives who were physical anthropologists. As he put it, they sort of dig up bones and talk about evolution of man from that. And I remember reflecting on that. I thought, you got to be kidding me. We're still using gross anatomy. We're looking at bones and just look at the bones themselves without any other information to try to decide about human evolution. I mean, to me, it was like thinking, well, how did the plane, where did the plane come from? Just by looking at the cockpit and the fuselage and the wings and the tail section without considering things like modern metallurgy, electronics, jet propulsion, and aerodynamics, everything of aeronautical engineering. And so, I just thought that it seemed so inappropriate to be thinking because I knew about bones at a much deeper level. And if you go to a museum of natural history, they're just going to show you the bones, mainly compare it to gorillas or chimpanzees, et cetera, to show how they're connected. But I knew that there were a lot of other things going on in the bone. So the first thing is functional capacity of the bone. I mean, how does bone get formed? All right. And I was aware that there's basically three different types of cells that form bone. There's osteoblasts, osteoclasts, and osteocytes, and they live right inside the bone. And the osteoblasts, they secrete a ground substance, and then they use enzymes to deposit calcium and phosphate to form calcium hydroxyapatite, which is basically the calcium that's in your bone. So this is what makes bones, strong and prevents them from breaking. Okay, but there's another part of bones that most people aren't aware of. The bones are the reservoir for the calcium in your body that you need. So it's very, very important that the blood level of calcium that it stays within a normal range, about 8.5 to 10.2 milligrams per deciliter. And if your level drops down around under 6 or goes over 14, the nerves and the muscles don't work anymore, and you die. So every doctor knows that hypercalcemia and hypocalcemia are deadly, right? So the body has to be able to control the calcium level. And how does it do that, right? So I'm going to talk about, this is the first control system we're going to talk about. There's many control systems in the body, but So basically, the thyroid gland is sort of shaped like an H in the middle of your neck, and each pole is something called a parathyroid gland. And these glands, these four glands, have receptors or can detect calcium in your blood. And based on what the calcium level is, it sends out a hormone called parathormone or parathyroid hormone. And so if your level starts to drop down a bit, it sends that hormone out and it attaches to specific receptors in the bone, and it tells the bone cells to release a little calcium. So to try to elevate the level. It also goes to the kidneys, and it tells the kidneys to bring back more calcium from the urine that's presently in production. It also tells it to activate vitamin D. And activated vitamin D, then goes to your gastrointestinal system and tells it to bring in more calcium. So you can see that the parathyroid glands are very important for controlling calcium, and that the bone is very important in that as well. So none of this is mentioned when you go to the Natural Museum of Natural History. And I wish it were, because I think if people understood what the bones actually do in your body, and how they're responsible for nerve and muscle function because they support the calcium, and then they would be thinking a little deeper and maybe thinking about intelligent design. And another, if you don't mind, I'd like to bring up another topic, and that is like another example of this, of just talking about how life looks and not how it actually works. And we're told that cold-blooded, water and life in the water, came on land, and and the gills changed, evolved to lungs because they needed more oxygen. Okay. And once again, this is very descriptive, and you can imagine there's no more information given to us about how this exactly happened. That's a heck of a lot of changes to make, right? But let's just mention a couple of other things here. If I told you, that your body, while we're sitting here talking to each other, that your body is using up about 250 milliliters a minute of oxygen. Okay, that's actually 100 million trillion molecules of oxygen every second. All right.
Wow.
And so if I told you to hold your breath, right, what's going to happen? Well, in a few seconds, there's going to be something to tell you to breathe, right? And so, the respiratory center, when you're using up oxygen, right, your body needs oxygen for energy, and it's making carbon dioxide. So you have sensors in the main arteries leading to your brain, and also inside the brain, that can detect oxygen and carbon dioxide. And so while you're holding your breath, the oxygen level starts to drop a bit, the carbon dioxide level starts to rise a bit, and the respiratory center in your brain sort of sends you a message in a few seconds. Andrew, we'd appreciate if you took a breath right now, because we like to hang around for a little while. You may want to hold your breath for a while, but eventually you take a breath. Okay. So if you compare that to besides forming the lungs, but we're talking about the cold-blooded animals in the water. Okay. Of course, they have a lower metabolism, less oxygen, and so the question becomes, in their control system, what was the set point? How did they know how their gills are supposed to breathe? And then on top of that, we know that our ancient ancestors, in order for them to be active enough to survive, in other words, prey on others instead of being preyed upon, or eat or being eaten, they had to be active enough. You use about 3,500 milliliters per minute of oxygen, and that's a heck of a lot of oxygen. So the thing is that in order to be able to do that, the lungs have to have the right functional capacity. So they have to be big enough. The volume has to be big enough. They have to be able to move the air in and out. The airflow has to be fast enough. And the efficiency of oxygen diffusing from the alveoli in the lung into the capillaries, the blood in the capillaries, has to be good enough so that you have enough oxygen. So none of these have been dealt with besides the structure. So my point here is that what I just talked about, the bones and the gills going to lungs, they just talk about how life looks, all right? Not how life actually works, just, within the laws of nature. And it doesn't talk about what life needs to stay alive. And so the question becomes, how can you have a theory about life without knowing how death takes place, how life doesn't work? Right? You need to understand that first. So this is what started me to write about intelligent design. I wanted people to know how life actually works and why it dies. And I want them for them to be able to ask better questions and to decide for themselves if neo-Darwinism made sense.
Yeah, very interesting. Yeah, I mean, there's layers of interdependencies, subsystems upon subsystems, that feed into larger systems. It's not, as you say, just how things look. When you're looking at the origin of animals from an evolutionary standpoint, it's not just how it looks, it's how it could possibly have been alive and what makes it alive versus dead, and these are important questions because there's so much information involved in keeping an organism alive. That's why life is so special after all. Well, I wanted to ask you how you and your co-author Steve Lothman, how you guys came together. You have different backgrounds, but you had a similar desire to tease out the arguments for intelligent design. How did you manage to come together and write these books?
Yeah, it's a good question. It was about 9 or 10 years ago. So I started writing about this material. I had this material out there on different websites, web columns. And basically, as I just explained, I was explaining how the body works and why it dies. Okay. And this involved, as I've already mentioned, control mechanisms and functional capacities. Okay. So for example, if we just talked about the respiratory system, we'd be looking at, the actual oxygen level in the blood or the carbon dioxide level. And if the lung function's off, like we see in people with emphysema, I'm a physician, so that's what I deal with, people who are smokers, etc., or they have something called pulmonary fibrosis, then I'm explaining, hey, this is when it works fine, the body's alive, but this is when it's not working right. And it has to be just right for it to work properly. Or maybe I was talking about, cardiac output or blood pressure or blood flow. So in other words, you got to get the blood to the tissues, right? It's fine to have oxygen, but if you don't have any blood flow, it's game over too. So I'm talking about the heart function and looking at heart failure, maybe valve issues or heart attacks, etc. Or maybe we're looking at having enough sugar or blood, glucose in the blood. So obviously we're dealing with diabetes. So, my articles were filled with numbers regarding control mechanisms and functional capacities, all that sort of stuff. And basically what Steve told me was, so I had an 81-part series called The Design Body on Evolution News for over a year and a half, from I think 2015 to 2016. And somewhere in the middle of that, Steve read it and he contacted me and he says, we need to write a book. And he says, you're writing about medicine, but what you don't realize is you're also writing about engineering. And I really think that the reason why he saw the engineering was because I threw in the numbers. I talked about functional capacity. Of course, I didn't know I was talking about engineering, but I realized that basically Darwinism or even intelligent design, it's a thought experiment, but the only way you know if it fails is with death. There's nothing in the Darwinian narrative where they talk about death. Okay, everything they think, every system they put together, it's all going to work. It never dies. Okay, but Steve and I, as I'm going to explain, we live in the real world. We know, this is what we do for a living. And if I don't get it right or he doesn't get it right, people die or people lose money. So it's very important. This is real life issues. So that's how we got together. Steve contacted me. He said, we got to write a book. And we started talking about that.
And it is a very useful thing to have a physician, one who knows the body and knows life in its bodily form, come together with someone who knows engineering principles. Why is that such a useful thing that those two come together?
Well, yeah, but I didn't realize it when he contacted me. But I did learn something, and this is a really, really good question because I had I was thinking about like, okay, what happened, and I really, prior to this, I had written this material at about 7 or 8 different levels, for kids and more simple, harder, whatever, etc. And then when we got together, I thought, oh, this is pretty easy. I've written this so many times, I'll just write it again, okay, and. But we had to figure out, well, where are we going to fit the engineering principles in? And I think 2 things that happened in our relationship and our interaction, which really brought home to me engineering. I've learned so much from Steve. But these are the 2 things I resisted intensely. I wouldn't, he kept telling me to do this and I wouldn't do it. All right. Remember, I'm a general practitioner, I'm a hospice doctor. So I've been dealing with all medical stuff. But the 2 things that he wanted me to write about, I didn't want to write about because I'd never written about it before. One was connective tissue. All right. So what's that? Well, multicellular organism, you have the intracellular space. So everything that's in your cells. And by the way, Most of the discussion you see about evolution or even intelligent design is intracellular. They're talking about molecules, they're talking about DNA, they're talking about enzymes, proteins, etc. And that's fine. It's sort of a bit of a pet peeve of mine too, because what we're talking about is the total body level. Okay, so in a multicellular organism like us, you got 30 trillion cells, but you've also got the extracellular space, something outside. So your body consists 60% of water. The cells are about 70% water, and the fluid out that surrounds the cells in between them is called the extracellular fluid, and that's all water. All right. So Steve used to say to me, "What's holding all this stuff together?" Okay, I mean, we know what happened to the Wicked Witch of the West, right? She melted, right? Because water really doesn't stand up for her. And I knew the answer to that was it's called the extracellular matrix, and it's made of protein called collagen, and you have elastins, etc. But I'd never written about it before. But his question was a very important question because he's saying, "What's holding it together?" Well, I didn't have to care about that. I mean, it's more surgeons and wound specialists are interested in that. But the second thing was development. Now, I'm not a neonatologist. The last time I read about how the zygote develops into a newborn, was maybe when I was in medical school, right? And he thought that was he kept pushing and pushing at that, and he finally said to me, besides how does everything stick together, he basically said, "Well, how do you build this from the ground up?" Right? So I mean, it's like I'm not thinking. This is the problem with biology and medicine, okay, physiology. All right. What I realize is that physicians are used to working with what we've got. Okay, I'm just trying to prevent the body from dying. Okay, but I didn't have to make it. But that's what the engineer has to do. All right, he has to do
Yeah.
everything I'm doing. He has to do at the end of the day. Once it's made, he has to make sure he or she has to make sure it's working. The bridge doesn't fall down. The building doesn't fall down. Okay, the machine keeps working, etc. So they go through this process of design, build, and test, right? And of course, it's always going to fail until they finally get the final answer. So this is why
Yeah.
he was pushing me, and I learned from that. I recognized that okay, this is where he's coming. This is why it was so important. And there's one other thing I want to add, which stamps this, okay? Because he and I would have this discussion, and it was a good discussion. And that's we talk about control, we talk about functional capacity, but this is the term he likes to use. It's called coherence. We have coherent interdependent systems. So the systems are dependent upon each other, but they're coherent, or there's coherence. And what does that mean? That means you have the right parts made exactly right, assembled properly, doing the right thing at the right times. Now, a lot of people would say that's irreducible complexity, and truly, that is true. I mean, if everything's out of whack or the parts aren't working, that's fine. But this coherence is irreducible complexity on steroids, okay, or
Mm.
order of magnitude above. And what do I mean? I want to go back to, in fact, before this interview, I did read looked at Michael Behe's part in his book on the Darwin's Black Box, because I want to go back to his iconic mousetrap. All right, now there's 5 parts, but let's just focus on 3 parts, okay? Because most people, when they think, well, you got to have 3 parts, okay? The 3 parts I'm going to talk about is you have to have a base, right? You have to have a hammer that's going to come and hit the mouse, and you have to have like a spring or coil that's going to give that power to the hammer, to hit the mouse, okay? But they never go beyond that, okay? The question becomes, what's the functional capacity of this? What's the base made of? It's got to be solid. It's got to be made of wood. Okay, the material specifications for that base has to be right. Otherwise, it could be plastic and flying all over the place, right? The hammer, right? It has to be solid, steel. It has to be strong, strong enough. If it hits the mouth, it's not going to bend or something. It's got to do its job. And the same thing with the coil or the spring. It has to provide enough. Has to have enough potential energy that when it makes the hammer go, right, it's going to go move fast enough and with enough power, right? And why is this? Because we're dealing in real life. We're dealing with a mouse that has the neck has a certain thickness, right? It has got a certain speed and agility, right? Otherwise, it's not going to work. This is the functional capacity of a mousetrap. Well, this is the exact same thing in the body. And this is why, this is what Steve and I would talk about. This is what people miss. This is what Darwinian explanations totally miss. It's one thing to explain how it looks. It's another thing for it to actually work. All right. And that's what we'll get into. But that's what our book talks about. We're explaining how it falls apart and what it needs to stay alive and continue. And that Steve sees the engineering. So that's basically, how we work that out together.
Yeah. helpful to come together. Yeah, so you gave him a new appreciation of the final product, as it were, the human body and all its amazingness. But he also, helped you to understand holistically how it all comes together. So a very fruitful partnership, I would say. That was Dr. Howard Glicksman discussing arguments from his new book, Your Amazing Body, co-authored with Steve Loffman. In a second episode, we dive into some of the astounding engineering problems the human body must overcome to stay alive: homeostasis, reproduction, respiration, and more. So don't miss the concluding half of our conversation. And by the way, you can watch this and other interviews with ID scientists and scholars on our new YouTube channel. Subscribe at youtube.com/@IDTheFuture. That's youtube.com/@IDTheFuture. I'm Andrew McDermott for ID the Future. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.